How many of these batteries do you need to connect in parallel to be able to drive this motor properly? My name is Janos, I've built 3 electric cars myself, and now I'm going to show you how to match the power from your source to the power requirements of your load. Let's look at it. Right, if you don't do these calculations, you risk overstressing your batteries and destroying them, or you buy too many batteries and you risk wasting space, weight, or your money. Let's start with the motor. So we know it's a 100 kilowatt motor. We also know the motor came from a 400 volt car. So what we can do is we take the 100 kilowatt and we divide the 400 volts out, and then we end up with 250 amps. Okay, that's great. That's our demand side. This is the current draw that the motor wants, right? So let's look at the supply side. Here's a data sheet for an 18650 cell. Okay, it's got 2500 milliamp hour capacity up here, okay. And then it's got half an amp standard discharge current, and then it's got 2.5 amp maximum discharge current, and then it's got this other one, 5 amp maximum instantaneous discharge current. Okay, surprising that they broke it out to 3. I expected 2 numbers there, but we can work with this, right? So 5 amp is not enough, we need 250, right? To increase the current that we can supply, we need to connect them in parallel. So let's get the calculator out and divide 250 divided by half an amp. Okay, we've got 500 batteries in parallel if we want to use the standard discharge current. In the same way, if we want to use the maximum discharge current, 250 divided by 2.5, that would be 100 batteries in parallel. 250 divided by 5 amp, the maximum instantaneous discharge current, would be 50 batteries in parallel. 400 volts, the motor, we also need to get to the 400 volts, so we need to put some of these batteries in series. So let's put 96 of these in series. So that gives us this notation here. 96S, 500p, that's 48,000 battery cells. 96S, 100p, that's 9,600 battery cells still. And 96S 50p, that's 4,800 battery cells still. Now, I've got another data point for you. A Tesla Model S has 7,104 battery cells. That's 74 battery cells in parallel. Okay, there's some simplifications and some pitfalls here that I need to address. First of all, there's loads of fake batteries. These ones allegedly have 6,800 milliamp hours capacity. That's certainly not true. Another one is the motor is a 100 kilowatt motor, and the draw and the output of the motor are not necessarily the same. We haven't even talked about inverters and battery management systems, and in our data sheet, instantaneous we haven't defined. Like, is that a second? Is that a minute? How long is it? Is it tenths of a second? We don't know. Okay, but from the data sheet, we can do a little bonus calculation here. We've got 96 cells in series and 100 in parallel. Now, if we times that 2.5 amp and the 3.6 volts, we get the available energy of the entire pack, which would be 86,400 watts or 86.4 kilowatts, which is quite a lot actually. It's quite a big pack for a car. Okay, let's do the weight as well while we're at it. 96 times 100 times 50 grams is 480 kilograms. That's also quite a lot for a car. So, not quite happy with either of those. So the answer of the calculation is between 50 and 500 batteries in parallel to run our electric motor. And the exact result depends on the weight, the cost, and the battery spec. So the cells that we saw in the data sheet, maybe they're not quite right. As an extra data point, I've given you the Tesla Model S, which has got 7,104 cells and 74 of those in parallel. But the approach that I've shown you is exactly what you do. So you calculate the draw of your load, you find a cell and its data sheet. In the data sheet, you locate the discharge rate and you divide the load requirement by the cell rate to figure out how many you've got in parallel. You also have to put enough in series. Cool. I ran you through a quick example here, and I didn't give you an exact answer, but hopefully this helped to sharpen your mind towards what kind of questions you need to answer when you're designing your battery pack. I've also made a little battery calculator here where you can type in those numbers and you move some sliders around to see exactly how much power you would get out of a given pack. So I hope this helped someone, and yeah, check out the calculator.